All right. Let's keep going, nerd burgers. Where's my why isn't my slideshow appearing? Here we go. We're nearly finished the nervous system. Right. Now what we want to talk about, we want to look at, oops, too fast. Here we go. So just to remind ourselves where we are. Sometimes the nervous system can be a little bit confusing for which part you're looking at. So let's have a look and remind ourselves. Remember, this is what we looked at in our last lecture. And remember that this part of the nervous system is really important with regards to keeping homeostasis. So now what we're going to do is we're actually going to look at this. We're going to look at the sensory part of the nervous system. Remember that the nervous system can be split up with regards to its anatomy and also with regards to its function. When we look at the function of the nervous system, we have a sensory part and a motor part. So now we're going back. Now we're going to look at the sensory part. How do we get the information to come into the central nervous system? All right, so I love sensory receptors because I love neurons, and because neurons are very special kinds of cells because they're kind of weirdos, but sensory receptors are just like ultra weird weirdos, like they are completely specialized, designed specifically for one specific job. Did I say specifically too many times then? I think I did. So these cells are amazing and they are designed to pick things up and monitor different things, and they're all highly unusual and unique for their job. Okay, just so you understand, you can have sensory receptors firing action potentials, and that's fine. But there's a difference between sensation and perception. So this part is just you can feel those sensory neurons firing action potentials. And this part is you're actually understanding what that means. So there's a few different parts. And yeah, let's have a look and see. So we have sensory receptors, and they are designed to pick up lots and lots of different stimuli. So there's two kinds of sensory receptors. There are the general sensory receptor, okay? And then you've got the sensory receptors for special senses, okay? So you have general ones and special ones. So two kinds of sensory receptors. So they all are equally as important, okay? So the sensory receptors for the special senses are the ones in the eye, in the ear, in equilibrium, smell and taste. So they're special. And then the general sensory receptors, they are the ones that pick up touch, pressure, pain, proprioception, where you are in space, okay? So just be aware that there are two broad categories of sensory receptors. Okay, here we go. So now we're going to look at the special sensory receptors later. We're going to look at the general receptors now, and there's so many, okay? And we're only going to learn about a few because there's lots and lots of them. Here is a guy that we know, nociceptor, okay? So he is classified as a general sensory receptor, and he picks up things that are noxious, okay, so not nice. And we've got myelinated and unmyelinated axons, yeah? And then here we've got thermoreceptors, pick up changes in temperature. Chemoreceptors pick up chemicals or chemistry, designed to detect chemistry, and we're going to have a look at those. Mechanoreceptors, these are big in the skin. We're going to look at those later. We'll come across all of these as we study. Keep studying 165 and 175. You'll come across them multiple times, okay? There's actually quite a few of these mechanoreceptors. Yeah, so we're going to see all of these. Don't worry. All right, so let's just focus on one kind of receptor for now in the context of pain. So the receptor designed to pick up pain is called a nociceptor. Okay, now this is what he looks like. All right, now he's a bit of a weirdo because here are his dendrites, but his cell body isn't here, it's actually here. But his axon is just, look at these axon, yay! So he's just like any other neuron, he's just built a little bit differently, okay? So the nociceptor is our sensory receptor for pain, and we have them everywhere except in our brain. I know. So, yeah, except the brain. So there you go. So that's why they can have people having brain surgery and the person is sitting there talking and that because they don't feel any pain. Yeah. Okie dokie. So, so what is pain? So this is a definition of pain. It's an unpleasant sensory experience. So the definition of pain has 4 parts. You're having an unpleasant sensory experience. That means these guys are firing action potentials like nobody's business. And this is here he is there, the red guy. They're quite long, hey? These nociceptors are quite long. Let's go straight to your spinal cord. But it's not only sensory, but it also is emotional, okay? Because look at this guy here. This nociceptor synapses onto this neuron here. So this is neuron number 1, neuron number 2. See how we cross over? Click. And then we go up. And we go to the thalamus, okay, where all sensory information kind of stops. It's like the central station for sensory information, and then we go to the brain. So it's got to do with emotions because the part of the brain where these kind of action potentials end up is in the emotional side too. Okay, so this is about sensation and this is about perception. So it's got a sensory part, it's got an emotional part because you don't like it and you remember it. Okay, and it's associated with actual tissue damage, so you actually are hurt, or potential tissue damage. So you can feel pain without having damage to your tissues. Yeah, so that is something that phantom limb pain. Yeah, okay. So there's 4 parts in the definition of pain that you need to understand. So pain is not easy. It's got multiple bits. Here is a pathway, okay? Here we go. Look, you've been stabbed by what looks like to be a nail, and then your nociceptor firing action potentials. Dorsal root ganglion. Here we go, come in from the back of the spinal cord like we know. So this is one neuron. And why is this bit bulgy? It's because these guys sit in there. Right, here we go. We're synapsing. We cross over in the spinal cord, and then we go up the tract, which is like a elevator all the way to the brain, and goes to the thalamus. Then it goes to the limbic system, and it talks to different parts of your brain. So these action potentials end up in many places. This bit says, oh, that was awful. I'm stressed out. Sensory information. Oh, it's coming from my finger. So action potentials end up in different places, and they tell you different bits of information. Okay? Right, there's different types of pain that we need to think about. Somatic pain is all about where the nociceptors are located, okay? So somatic pain involves the activation of nociceptors in bone tissue, okay? It's an example. So you can localize it, it's constant, it's aching. Whereas visceral pain, okay, is the nociceptors are located in different places, okay? So somatic pain versus visceral pain is just, the difference is which nociceptor is firing action potentials, okay? Now, if your nociceptors in your cardiovascular, respiratory, and urinary tract are firing, usually this causes a referred pain. Okay, so this one you can kind of localize where it is. This one you have to kind of work it out. So what do I mean by referred pain? So the visceral pain comes from nociceptors in your organs. Okay? And usually you've got to work it out where it comes from, because the pain that you feel, okay, so if you have the nociceptors in the heart going off, then you're actually feeling it in your skin. So it's a little bit tricky to work out which organ is activating the nociceptor in visceral pain, because it's usually referred. Okay? So heart attack, okay, you're having tissue damage, nociceptors are going off, but the pain that you feel is down your arm. Okay? Another one is if you have a ruptured spleen, okay, you get pain here. So the visceral pain is a little bit trickier to kind of work out where the actual, or which organ is activating the nociceptor. And this is because of this, if you want to understand it fully. So here is the neuron coming from the heart. Can you see how it goes into this spinal nerve? And then this is the neuron from the nociceptor coming from the skin. So these are two nociceptors, right? And they all end up in the same spot in the spinal cord. So the issue is that your brain knows that you have pain here, but it doesn't know whether it's coming from your skin or your heart. Okay? So you don't really need to understand the anatomical reason why that is that your spinal cord is getting two bits of information. It's getting pain. It knows that it is pain, but it doesn't know whether it's coming from here or here. It just knows it's getting pain in here. Yeah? That's how you get referred pain. It's just the way that the nociceptors are coming back into the spinal cord. Yeah, so that's interesting.